All right, so let's get started. I'm very happy to introduce Daniel Ben Yosef, one of our data solutions engineer, who will be taking us through today's webinar. We'll be discussing sharding within the context of scaling MySQL, why sharding MySQL requires more effort over time, as well as replicating from MySQL to a cloud data warehouse. So without further ado, I'll hand it over to DBY. DBY?
Thanks, Tasha. So today, essentially, like Tasha mentioned, we're going to talk about sharding MySQL. How do we get the data that we're sharding into a proper analytics strategy as well that would fit our business model? And pretty much how do we tackle that problem from the angle of both how we scale our data within our OLTP database, and then we'll talk about how do we replicate it into OLAP. So essentially maybe an MVP store or any of the stores that the cloud would give us. So let's talk about sharding MySQL, right? That's our first challenge. How do we go about this? What are some good strategies? What are some good tools that we have in order to facilitate that problem? So here's a good thing to do. The good thing to do, the best practice to do when sharding MySQL is functional sharding, right? Now, what we used to do I like to say back in the day, but it's probably like 3 years ago. We used to just split either our app to do reads from replicas, right to one master, or maybe have a two master replication when one side of the app would write over there. And then maybe that replication would break every once in a while, and you get your bells and whistles and pager duties at 3 a.m. Trying to fix that server. A lot of fun. So those apps used to do, you'd split it in the ORM. You'd say, hey, read from replicas, and maybe some reads would have happened from master, but very, very, very few. So functional sharding essentially says, apply specific logic to the data set and just divide it into either a few databases or a few databases on different hosts or different regions, or pretty much anything that works logically with the way that your app and your data set is structured. So if we take the classic example of countries or geos, right, essentially we would want our sharding strategy or partitioning strategy could be by continent or by country or by state or city, depends on what scale you're working at, right? So we say everything that has to do with the EU will go to this host or this group of hosts or this cluster. All right. So now we actually have some sharding going on, right? We might have implemented in our app, we might have implemented the logic in our app or in the ORM, or we might have implemented it using one of the tools. So we might have used Proxy SQL, that's backed by Percona. We might have used Max Scale, that's backed by MariaDB, where we've configured sort of our sharding strategy or our query rewrite, and we have our groups and hosts, and that component knows how to route those queries properly, so the writes and the reads themselves. And we hope there's some caching over there, by the way. Highly recommended. So the question comes to say, okay, we've scaled our data, our OLTP works fine. Read times are better now. We're doing less full table scans, and the ones that we do are on a much smaller data set, so they come back a lot faster than they used to. Everything's working fine. We're able to scale pretty much horizontally at this point. There comes a question, okay, so now that data set that I've had in maybe one host or one database is now in multiple databases across multiple clusters. How do I analyze that data, right? I might want to run joins. I might want to see everything for all the continents in the same context of one table or two tables. How do I wrangle all this data back together to essentially run the analytics that my organization is expecting me, right? So the good news is it is possible, it is doable. Essentially, you'll have to treat all those databases and all those shards as separate event streams, right? If you take all those event streams and you replicate those into a cloud data warehouse, essentially you'll get the benefit of analyzing everything under one table. And what we used to do again is trying to, we've had everything in one host, everything in one database. We ran our business query on one of the replicas in the OkCupid MySQL cluster. It might have ran overnight, and we'd come back in the morning to see the results, which is already like 12-hour delayed, very much far than the real-time needs that we have today. So if we go about all those event streams from all those shards, right? Essentially, they are one table, where we would treat the uniqueness or the primary key usually as a composite key on the cloud data warehouse itself. So we would take a shard identifier or a DB identifier as well as the primary key, right? Because if, for example, our primary key in those tables is, auto incremented ID, just throwing it out there, MySQL users, you know what I'm talking about. If those IDs overlap, right, we don't want that overlapping or that primary key conflict. So we will add a shard identifier probably, or a schema identifier, anything that helps the uniqueness of one of those rows, right? And then we would keep replicating the event stream that's coming. So the event stream would be the updates, the inserts, and the deletes that are happening on those specific shards, and have them reflected in our data warehouse. Actually almost covered most of this on this. So the challenge essentially is, okay, we have the event streams going over there. We built some of this replication. How do we maintain it over time, right? So what we used to do again is query in the old OkCupid database. It was very slow. It was not really performant. Might not have answered our business needs. Hard to make decisions over data that's 12 hours old or even 24 hours old. Really was counterproductive. Now, when we get the data replicated to a cloud data warehouse, maybe it's an MPP store. Any of your public clouds, really, they all have the good offerings for decent cloud data warehouses with good performance that really auto scale for you. Then those queries can turn from anywhere from 15 hours down to 10, 20 minutes on this entire data set, right? Because it's built differently. OLAP databases and MPP databases just work differently, and they're more performant for that kind of, for that size of data set and the kind of workload and questions we want to ask our data. Okay, so we're replicating our data sets and our shards into a cloud data warehouse, right? Everything's nice and dandy. We can run the queries. We've created maybe the initial DDLs we created ourselves, created the tables, created the schemas. What happens next, right? Somebody makes a schema migration on one of the shards. Maybe it's just one of the shards. Maybe it's all the shards. Maybe somebody dropped a column. Maybe somebody added a column. Maybe there's a PK change across the shards. What happens, right? If you manage those migrations or schema changes manually, what you're going to find is that it's going to break often. It's going to break often, and you might risk losing data, losing some of the changes, or having to redump or reread those, either an entire shard or just some tables from a shard. And if those tables are huge, they can take time, and you've already lost a day or 2 days worth of analytics. So you're essentially losing money, losing insights to the business. Now the solution here is actually to automate that process. One way of doing that would be reading the source schema either periodically or maintaining something like an Avro schema or a JSON schema service that can say, oh, I see this event stream over here coming in from this shard or that shard, and I see something's changed, right? It's not like the state of the schema that I currently know. Let me go ahead and see what happened there, fetch it, and then have a conversion tool or something that knows how to convert to the appropriate cloud data warehouse types according to what you're using. So again, manual conversion breaks often, breaks easy, potential data loss, automatically mapping or inferring a schema. It could be very complex to develop, but even with some static mappings, you'll be able to get it right or as close to right fairly quickly, to be honest. So that should take you long way. I mean, this should really bring you out there and help you convert your schema as well in that case. All right, so just sort of to go through what we were talking about today, we're talking about sharding and replication in MySQL. Again, sharding and replication in MySQL. We talked about partitioning a little bit. So partitioning is kind of it's a gray area. Some customers that we see will use partitioning, even though it's probably not as performant as functional sharding usually. Where one of our largest customers, we'll talk about them next, do use functional sharding, and they replicate from MySQL to Redshift successfully. And second, and maybe the most important one when we're talking about analytics, is to migrate OLTP workload into OLAP, right? So if we're talking about the basics of this, it means you still want to use your OLTP databases for what they're great at, which is serving your production needs, right? Your production app. It can be a web app. It can be anything else. But essentially, MySQL or other OLTP databases serve this purpose very well. As far as analytics goes, you want to be able to leverage one of those modern cloud data warehouses that really give you column stores, that really give you performant query times. They can ingest fairly large data sets in very short periods of time. Like the deck says, sorry, one sec. Migrating your sharded OLTP data to an OLAP data warehouse increases productivity and reduces time to insight. Again, that query that used to take us 15 hours or 13 hours on MySQL will now take us literally 10 minutes to run on something like Snowflake or Redshift or Azure SQL Warehouse or BigQuery.
Awesome. Thanks so much, DBY. If you haven't done so already, please send us your questions in the chat panel. We've had a few come in and they're looking to be pretty good. All right, so DBY, how would you go about migrating multiple MySQL instances to a single Redshift table, or say into BigQuery or Snowflake?
That's a good question. What I would do, and I think I mentioned it on one of the slides, again, you want to have something that watches the bin log on any of those, right? And knows how to apply those statements into a form of an event stream, where an event can be like an update, an insert, or a delete. Now, as soon as you have those, you want to pour them all into a staging table, right? So you have the event stream table, and from there you can do things like type 2 SCD, type 4 SCD, have the record that's most up to date. It's really fairly easy. There's so many projects that will let you watch the bin log in pretty much any language that you'd like. I highly recommend the Python one, this Python MySQL replication. Just look at it, fairly easy, lets you even do a dump of the bin log stream into a dictionary form, and from then on, it's very easy to process this, even build it into a CSV or a JSON file, and then copy it to whatever data warehouse you'll need. Now, keep in mind that you'll have to maintain that uniqueness per shard, right? So in addition to that primary key that you already have, that could be that auto-incremented ID or a UUID or something else, you want to attach it with something that's really unique. So either a UUID that happens that's saved into the OLTP database, or manufacture one or an artificial one that is attached as part of the metadata, which could be the the shard ID, the host name, anything that would give you uniqueness in that case. From then on, you can pretty much do anything on the data. You can run this crazy window function if you want to rank something. If you want to get this data ready for ML or AI, it's very easy to do once you have it set up in this cloud data warehouse.
Great. All right, let's look at another one. Oh, sorry, quick follow-up on that. Do you guys have any customers that are currently doing this today?
We do actually. One of our customers, OkCupid, actually leverages LUMA's replication for various MySQL shards into Redshift. Right. So if you have a table across multiple shards and you want that table replicated into Redshift, that's something that LUMA can help you do in high volumes, if I might add. Where we would capture all the events that happen on those tables and those shards and replicate them into Redshift. Now, since those essentially are one table, right, just across multiple shards, we can help you load those into one table in Redshift or Snowflake or whatever other data warehouse that you like. We can either take care of upserts for you as well, or the type 2, type 4 SCD queries can automatically be handled by LUMA as well.
Great. Okay. So next question is, why would you want a data warehouse solution that auto scales?
Oh, thanks, Tasha. I'd say that's an easy one, right? You're thinking about, okay, maybe I've had Informatica, or maybe I've had something else for a while, and my data warehouse was just another OLTP one, or I had an EDW built on top of Oracle or SQL Server, right? And for those, maybe I was in my own data center and I had to, if I wanted to scale those up, I had to literally go and buy extra storage cabinets, right? If you remember how fun that is, then you probably know that the answer is to the question, why would I want a data warehouse that auto scales, right? I don't want to have to worry about it. If I can avoid any sort of DBA activities, or assigning specific engineering resources to manage those services, if I can avoid that, there's just winning right there, because you don't have to assign any engineers. You can have them focus on actual analytics, doing interesting things with the data, as opposed to, wait, let me build that index again. Let me see if those keys are optimal, right? With most of those cloud data warehouses, we don't need that. We don't need any of that, right? Because it takes care of itself. They maintain themselves. And they auto scale, right? And if they don't auto scale, then they would scale in a click of a button. You say, hey, give me more resources for this query specifically. So I think that granularity and that level of control is really ideal.
Great. All right. Let's see here. Okay, we have another one. It seems like a lot of times start, even for myself, with MySQL for analytics, but we know we have to migrate to the cloud data warehouse as our data needs grow. Like, why is that? Maybe we should we have just started with a cloud data warehouse instead of having to deal with a bunch of MySQLs?
Well, it's a good question, right? Maybe you have a website, maybe you have a mobile-facing API, maybe you're managing users in any capacity. You're more likely than not have either MySQL or Postgres in there. I think if we ran a survey, it would show that MySQL is the most popular one out there. And if you maintain your analytics in your OLTP database, it will only get you this far. It'll only get you so far. I can testify that even if a data set it's not extremely large, 5 terabytes for one database, not extremely large, even if it's well indexed, your analytics queries across those tables will not be super fast. It has to do with InnoDB and the disks and the hardware that you have over there. And if it's an Aurora instance, so it really depends on AWS whims and what they decide to do or allocate, or if you need a bigger cluster. But the thing is that with InnoDB and MySQL in particular, as much as you'll increase it, the type of queries that you'll be running for your analytics workloads will just not scale. They just really counter each other. The workload and the queries and the way that the data is actually stored, it's not optimized for those kind of queries. So, I mean, you can go with your OLTP database, and many companies do, by the way, for a year, for 2 years, but then you get your user growth. Things start to scale. Then the query that used to take, 4 hours now takes you 15 hours, right? And that's where you feel like, okay, I need to start thinking about replicating the OLTP data into a cloud data warehouse.
Okay, looks like we got a quick follow-up on that. It's like, so if MySQL is the number one, is it still part of the modern stack today? And what type of versions are you seeing out there in the wild today?
That's a great question. People might think that MySQL is not being used that much anymore, but you'll be surprised to see it in most of the stacks, either here in the Bay Area or a lot of customers that I've talked to from from America, from Australia, anywhere. It's very likely that you'll find a MySQL stack in MySQL at some point of the stack with any company that you know. You know, anyone from Facebook who's worked a lot on MySQL to Google, who also use MySQL for one of their ad services as well as their Google Cloud offerings. So it's still out there. It's fairly widely used. I think one of those reasons is due to the fact that it's been out there for so long. MySQL is almost 20 years old. So the knowledge base that exists on the internet makes it really easy to maintain. There's dozens of blog posts, consultants, and what have you to help you use MySQL in an ideal and optimal way. As far as versions go, so I think 5.5, 5.6, 5.7 are the most common ones, with 5.5 almost being to the point of not extinction. I'd say that's something that'd be more relevant to MySQL 5.1. But everything from 5.6 and above are the popular versions. I think people who use the cloud versions like RDS or Aurora are by default on MySQL 5.7. And I have to say, I've been following fairly closely on the development of MySQL 8, which is very interesting, but I haven't seen or heard about somebody that uses it in production. What I have seen actually is something very interesting, where you get all those forks, not really forks, but people who would implement the MySQL wire protocol over this crazy databases written in Golang or in Rust, who implement things like Raft consensus for consensus purposes, and have RocksDB underneath. There's many paths that MySQL community is taking today, in parallel to the Oracle development, where they're optimizing InnoDB and all that stuff, whereas other parts of the community, mostly pushed by Facebook, are looking at RocksDB as the main engine over here. Now there's many interesting uses and versions out there. At the end of the day, like any other tool in software, it really depends on what problem you're trying to solve. I guess does that answer that? I think it does.
I believe so. I don't have a quick reply on that one, so we'll move on. But we are ending close to the end of our webinar here, and so we'll take one last question. It says this talk, you talked a lot about MySQL, seemed very knowledgeable, as well as how to get it to a cloud data warehouse. But you didn't really talk about LUMA, and where do you see that fitting?
That's a great question, which I happen to know a little bit about. Where LUMA fits in there is right between your MySQL and a cloud data warehouse. So the automatic schema inference and detection is something that LUMA does. If the schema changes, we will respond to it. If things break either in the middle of the pipeline or on the warehouse side, we'll respond to it. We have various amounts of safety nets to sort of keep your data intact. LUMA delivers data exactly once, so there's no problems over there. We would automatically essentially connect to your bin log, tap on each one of those shards, and help you get the data over into one table, multiple tables, apply type 2, type 4 SCD to those, get daily snapshots, anything that you can come up with when you have all that data in a centralized cloud data warehouse is something that LUMA can help you do.
Awesome. Well, on behalf of DBY and the rest of the LUMA team, we want to thank everyone on the line for joining us today. We hope you enjoyed the discussion as much as we did. We look forward to having you on another webinar. If you have any further questions, feel free to reach out to us. We'd be happy to answer them. Have a great day. Bye.